Welcome to Evidentia. We curate large volumes of science data and documents. How we do this is through evidence scans. So you specify your research goal. I want to make insulin from baker's yeast with DIY protocols. And we'll have a research agent help you refine your research goals so we can find the right documents for you. We can process up to 5,000 documents through our web app. You can see here it's asked me the first question. I'm just after any insulin-like proteins. I'm not trying to make actual insulin for consumption. That would be irresponsible. I'm just doing a fun little science experiment. You can see here it is still asking me some more questions. This is fun because I've always wanted to do this experiment. Include all human insulin and all insulin growth factors. And it will keep asking me questions until we have refined this down into enough details that we can find the right documents for us. Here we go. We want all the technical parameters. I want an end-to-end coverage in the document space. Now it has taken that and created a research goal. So we can see here, and this seems pretty accurate to me. It is quite a detailed and specific goal. And we are going to continue on. Now you'll see we have 4 options here. It all starts with the evidence scan. So this is where we build that foundational knowledge corpus. And it can be up to 5,000 documents, depending on how broad your research goal is. We'll build this foundational knowledge and provide a high-level summary of that. Then we can do a second deeper extraction layer called data extraction, where we take that corpus of knowledge and you specify a schema, and we will pull out any data we can find matching that schema. We can do batch extraction up to 100,000 documents. And this is a custom service. So if you find a particularly promising data set from your 5,000 documents, we can build this up to 100,000 documents. And this will provide a really detailed data set for a particular aspect of science. Finally, we have unpublished data, and we get this through collaborations with academics. And this is particularly useful if you're after negative data, the kind of data journals reject. Scientists are really eager to find a way to publish that, so we get great engagement. For this video, I'm going to continue with the data extraction. And you can see here, it starts with putting the different documents into buckets. This is a part of the evidence scan. So we get all of our documents and we put them into these buckets. And you can see here, it has pre-filled it based on my research goal. Now, I'm particularly interested in the DIY hardware because I don't have access to a lab. So this is looking good, and low cost reagents. If I wanted to, I could delete these or edit them manually. I can also use this assistant here to add or remove them. But I'm going to continue on. And you can see here, now we have our schema. Now this would not show up if I selected evidence scan. It only shows up for data extraction. And this is the schema. We are going to rigorously review all the documents to pull any information on these topics. And you can see here, again, I was interested in the DIY low cost features. So this is pretty good, but we could add columns if we wanted, either manually or with the assistant. Now we have our source filtering, and we had lots of people requesting this. You can see the first step is why we added it. I don't actually need clinical trial data. This is not for human consumption. This is just an experiment, so I'm going to skip that. However, I am very interested in these theses. We found almost 144 theses, and we all know how creative doctoral students are. So I think there will be some interesting methodologies in here that will be very useful. I'm going to take all of those. Patents are also another excellent source of data, but are commonly underutilized in academia because they're so hard to read. But we take care of that for you. So I'm going to take all those patents. Finally, we have papers. This is what everyone is familiar and comfortable with. And you can see here, we have some different filtering options available. So we can filter by year, and this is actually available for any of the sources. And then papers in particular, you can filter by license, journal, H-index, if it's available for the authors, and the citations. It's found 110 papers, so this sounds pretty good. It's important to note, though, that to show that we also show all matches. And we set the default setting to full text because you get a much better data extraction. But if you want a broader analysis, you can do all matches, and we will extract information from the abstracts, but obviously it won't be as rigorous as when we use full text only. This looks good to me, so I'm going to save and continue. Now we are doing our first data extraction and showing you a sample. So we are going to process 3 documents into buckets and show you what that looks like. So you can see here, we've done a paper and a patent, and we found this information for expression vectors. You'll notice it says exact match here, and this is how we deal with hallucinations. In these quotes is the exact word-for-word information from this source material. So if I went to this paper, which I could by hovering here and going open, I would find this sentence and know this is actually true information and has not been hallucinated. Now, overall, it's looking like we have got some good information from our buckets, so I am going to continue. Now we have the schema. This has done the same thing for that second, more rigorous step. You can see it has done a patent here, and based on our tables, it has extracted a lot of information. And this is what I was particularly interested in, the DIY aspects of how they have done this. And so there are some information here around the plasmid homogenizer, And they've even offered a low-cost alternative, which is quite good. That is what I'm interested in because I don't have access to all this fancy lab equipment. But you can see just how detailed this extraction is. And this is what we specified. So we are turning these messy PDF documents into this structured table of information that we want. Now we have our final review, and you can see here we're going to process 440 documents. Now we can process about 1,000 documents an hour. So this is going to take about 30 minutes. And we saw an example here of just a couple documents in the scan review and one document in the deep extraction. And we will now do that on all these documents to build our structured knowledge corpus. So I'm going to submit this here, and I'm going to receive an email now saying it has been submitted, and I will receive an email once it has completed. While we wait for that, I might show you some completed topics. So you can see here, we have a very broad topic that was an evidence scan. We processed over 5,000 documents, and this is what it looks like. So it shows the research question. In this case, we're interested in CRISPR engineering, and then it provides a high level summary. You can see all the citations there, and these have all been verified, as we said, with these quotations. We also have our buckets in the evidence section. So you can see the different buckets here, which were specified. And this is in a table format, so you can search it and export it as well. Now you'll notice there's two numbers at the top here. That is our verification. So we found almost 4,000 relevant papers and we verified 840 of them. 16 need review and about 800 are missing text. This is quite common. We'll find about 50% are available in their full text. And we have around over 2,000 that are not relevant, because as we have done a deeper data analysis, we deemed that actually a lot of these documents weren't relevant to our research goal. So we filtered them out, and you can have high trust that these documents are the ones you want. This is a good time to talk about our research agent, because this is a way that you can navigate all these documents. We have over 1,400 verified documents. This is high trust, and you can ask questions specifically across these. And you'll notice there are different filters here. So we can include the internet search if we want, and we can also filter out different sources. So you can see I've just asked a general question across all of these sources, and it is thinking about this right now. While we wait for that, I'll show you the expert network. So this is how we get unpublished data. We reach out to experts working in the field, we build their profile based on their publications, and we find they are particularly interested in sharing their negative data that the journals rejected. This boosts their publication and gives us a platform to share this data that is so valuable but is missing in science. You can see here now that the research agent has finished and has answered that question for us across these different topics. I'll continue on to our data extraction. Now you can see here, we haven't actually run data extraction on this topic. We just did the evidence scan. So I'll show you, we could have run a data extraction after running the evidence scan, but I'll show you this example here. So we can see in the data extraction, we have this table and it's very detailed, just like we had in our evidence scan we ran. And you can come across and see all these different rows and columns. We got 223 rows from 38 documents. We can search it like a database and also download it as a CSV file. And we have our 9 columns here. The last thing I want to show you is that we can actually specify the research agent to answer specific questions. So in this case, we can ask about the visible rows in this data extraction, and this will just answer in regards to this specific set of data. It will ignore the rest of these documents and it will just answer in our database. And I've asked, what are the strongest findings in this table? So you have different levels which you can use the research agent. You can ask it across the entire corpus of knowledge. You can ask it across the data extraction, or you can ask it across specific documents and specific data extractions. This gives you a way to navigate the large corpus of knowledge across science to find the information you need for your experiments. We're really eager to help companies commercialize their research faster by helping you avoid dead-end experiments and focus on that truly novel science that is groundbreaking. If you want to give it a go, please reach out to us and we'll be happy to help you get set up on Evidentia.